All right, let's dive in. Today, we're cracking the code on one of the absolute backbones of programming, Java methods. And you'll see how these things are secretly powering everything from the food delivery app on your phone to, even the office photocopier. Let's get started.
I mean, that's just wild, right? Think about it. For every single order, you'd have to go find all the ingredients, figure out the recipe, learn how to use all their crazy kitchen equipment. It would be complete and utter madness. Well, that's precisely what coding without methods is like. A total nightmare. Just pure, unstructured chaos with the same lines of code repeated over and over and over again. But luckily for all of us, there's a much, much better way. So here's the game plan. We'll start with their number one superpower, reusability. Then we're going to take a method apart to see how it ticks. We'll explore how one name can actually do many different tasks, and then we'll unpack something I call the photocopy principle. And finally, we'll put it all together and see it in action. Okay, so what's the big idea with methods anyway? It really all boils down to one incredibly powerful concept, reusability. Why on earth would you ever want to write the same piece of code more than once? At its core, that's all a method is. It's just a block of code that you give a name to. It's designed to do one specific job really well, whether that's calculating a total, displaying a message, or grabbing some data. It's a tidy, reusable little package of logic. Let's circle back to that food app for a sec. You know that feeling when you're starving and you keep tapping the track order button? The app doesn't have to reinvent the wheel every single time you do that. It doesn't write brand new code from scratch to find the driver, check the traffic, and guess the arrival time. Nope. Instead, it just calls one single pre-written method, something simple like track order. All that complex logic is tucked away inside this one method, and it gets used again and again for every order, for every person. That right there is the magic of reusability. All right, so we get the why. Now let's pop the hood and see the how. What are the essential parts that make a method actually work? It's time to take the machine apart. Think of it like this. Every method has a signature, and it's built from three key ingredients. First, you've got parameters. That's the information the method needs to do its job. Second, the return type. That's the answer it hands back to you. And third, of course, is its name, which tells you what it actually does. Okay, parameters. Let's make this super simple. Imagine you're booking a movie ticket online. You can't just click a button that says book ticket. The website needs more info, right? It needs to know which movie, what time, and which seat. Those specific details, those are your parameters. And in code, it looks just like you'd expect. The book ticket method needs you to give it a movie name, a time, and a seat number. This is what makes the method so powerful and flexible. Without these parameters, it could only book the exact same ticket every single time, which isn't very useful, is it? Now, methods can give you something back, or they can just do something. Think of a notification that pops up on your phone. It does its job, it notifies you, and then it's gone. It doesn't give you anything back. In Java, we call that a void return type. It's like, hey, just do this thing. I don't need a receipt. But other times, you absolutely need a result, like when a method calculates your electricity bill. It does the math and returns the final number to you. That return value could be a number, some text, you name it. Okay, this is where things get really cool. We know we can give a method information, but what happens when you want the same kind of action to work in slightly different ways depending on the information you give it? This is where Java gets really smart. This nifty trick is called method overloading. The idea is brilliant in its simplicity. You can have multiple methods with the exact same name, as long as their list of parameters is different. You can either have a different number of parameters or different types of parameters. The best way to think about this is checking in at an airport. The action is always check in, but the process is totally different depending on your situation. If you've just got a carry-on, it's a quick process. If you have two huge suitcases, it's a different process. Flying internationally, well, now they need your passport too. See, same action, check in, but different versions based on the context. And here's what that looks like in code. We've got three methods here, all named print details. If you just give it a name, Java is smart enough to run that first version. Give it a name and an age, Java automatically picks the second one. It's a super elegant way for your program to know exactly what you're trying to do. Okay, deep breath. This next part is something that trips up so many people when they're starting out. But don't worry, we're going to make it super, super clear with a dead simple analogy. It's all about how Java keeps your original data safe when you pass it into a method. And this is the secret right here. Just think about it. You go to a copy shop with an important original document. You hand it to them. Do they start scribbling on it or folding it? No way! They put it on the machine, make a fresh copy, and they do all their work on the copy, leaving your original perfectly untouched. This is the perfect picture for what's happening. Your original document? Totally safe. The method? It only ever gets to play with the photocopy. Whatever marks or changes it makes, they only happen to that copy. Your original is pristine. And this is exactly what Java does. It's a principle called pass by value. When you pass a variable like num into a method, Java doesn't hand over the original thing. It makes a quick photocopy of its value and gives that copy to the method. So no matter what the method does to its copy, your original variable outside the method is completely safe. All right, theory time is over. We've talked about reusability, parameters, return types, overloading, and that all-important photocopy principle. Now let's assemble all these pieces and see this machine run with some actual code.
So check this out. First up, the return type. We call calculate bill with the number 120, and boom, it does its work and returns the value 960. Then we see overloading. We call print details with just a name, and it prints just the name. We call it again with a name and an age, and it knows to use the other version to print both pieces of info.
And now for the grand finale, the photocopy principle. We start with our variable num set to 10. We pass it into the update value method, and inside that method, its copy gets changed to 60. But, and this is the magic moment, when we check on our original num variable back outside the method, look at that, it's still 10, untouched, unchanged. The original was protected. So at the end of the day, methods are what turn programming chaos into organized structure. They're the workhorses that let us build huge, complicated apps one manageable piece at a time. This brings up a really interesting question, though. If methods organize our actions, how do we organize our data and the actors themselves? We'll dig into that next time when we explore how programs can inherit traits, just like families do.